There's something backwards about orbital mechanics. Outer planets have longer years than inner planets, and higher satellites take longer to orbit than lower ones. And that's not just because those orbits are longer paths. The orbital speed is literally slower in higher orbits. The formula for orbital speed is clear. As r increases, v decreases. But if you're in a low circular orbit around Earth and you want to get to a higher, slower orbit, you can't just slow down. That'll send you falling down toward Earth. So higher orbits are slower, but you have to speed up to get there? This is the first in a series of paradoxes about space navigation, some of which I didn't even know about until very recently. The solution to this first paradox, how do you get to a higher, slower orbit if slowing down makes you fall? The solution is to remember that not all orbits are circular. If you speed up, you'll have too much speed to stay in a circular orbit, and instead you'll be flung farther out from Earth along an elliptical orbit. But on the way, you'll slow down like a ball thrown upwards in the air, trading kinetic energy for potential energy, or trading speed for height, eventually slowing down and starting to fall back toward Earth. But unlike a ball in the air, once you're at the top of an elliptical orbit, you can choose to speed up again to not fall back to Earth as quickly, and thus put yourself into a new circular orbit at this higher altitude. This two-step elliptical strategy is called a Hohmann transfer, and even though you speed up twice to get to a higher orbit, you lose even more speed due to gravity on the climb upwards, so the final orbit is slower. And that's the explanation for the first paradox. So, here's the second one. To catch up to a space station in circular orbit, you need to slow down. Really. If you're following a space station in a circular orbit and you want to catch up to it and dock, then you have to do the most counterintuitive maneuver possible. Slow down. If you did the seemingly obvious thing and accelerated towards the station, the higher speed would fling you onto a new elliptical orbit where A, you end up farther away from the planet, and B, as you climb, your spacecraft slows down, which means you'll end up farther and farther behind. To catch up to an object orbiting ahead of you, you actually need to accelerate directly away from the object, which slows you down so that you fall inwards along an elliptical orbit. As you fall, you speed up, which allows you to catch up with the object you're trying to catch. When you meet up with it at the high point of the ellipse, you'll be in the same place, but you'll again be going slower, so you need to do a second rocket boost, this time forwards, to stay in a circular orbit. And now you've caught up and are ready for docking. This paradox kind of reminds me of the Brachistochrone curve, where an object that first falls quickly downwards can catch up with one that's following a straight line. But anyway, that's just a taste of the weirdness of orbital mechanics. For example, did you know that it takes less fuel to leave the solar system entirely than to get into a circular orbit near Jupiter? It's just bonkers. And that's not even the most ridiculous thing. We'll talk about it soon. 9 years ago, I got this power bank from Anker, who's sponsoring this video, and I still use the bank and single outlet 30-watt charger it came with. In fact, today I'm using it to power a baby monitor to keep tabs on my napping kid. But a lot has changed since then. I mean, I have a kid now, but also chargers now use gallium nitride instead of silicon for their electronics. It's more efficient and so can be much smaller for the same output. Anker's newest chargers are still small, but have way more power output. Plus, they have multiple ports and will auto-detect your devices, monitor real-time status, and dynamically adjust power output for optimal charging between ports, whether you have a phone and a laptop running full bore, multiple phones, or a 3D model of an atom and emergency satellite beacon plugged in. They call this Power IQ 5.0. Their chargers are designed to avoid overheating, improve battery lifespan for your devices, and keep you informed about what's going on. To see how Anker is continuing to push the limits and solve real engineering problems in charging, check out the link in the description, and thanks to Anker for their support.